Domain generalization tackles the problem of learning a model that generalizes to data drawn from a target domain that was unseen during training. Here we only have access to multiple sources of data that might come from different distributions, but we don't have access to target data that comes from another different distribution. In single domain generalization, instead of having access to multiple sources of data, we only have access to a single source domain. And this is challenging but realistic case. Challenging because we need to be able to generalize from a single source data instead of multitudes of distributions, and realistic because in reality collecting a set of distinct domains is time consuming. So it's more realistic to be able to generalize from one single domain. In this paper, we tackle the problem of single domain generalization by using center-aware adversarial augmentation. Generally speaking, the existing single domain generalization approaches aim to generate hard examples to confuse the classifier, and this may make the classifier robust to small perturbations. However, the generated samples are typically not diverse enough to mimic a large domain shift, which itself results in suboptimal generalization performance. To improve this, we propose a center-aware adversarial augmentation technique that expands the source distribution by altering the source examples so as to push them away from class centers. Previous methods try to generate hard samples to confuse classifier, but these may not sufficiently expand the distribution of source data, but rather create samples close to the decision boundary. But our method pushes the samples away from the class center to expand the source distribution, so it increases the chance of covering the span of target data, as you can see here. At the same time, it maximizes the margin between classes as we encourage samples to cluster around class centers. You can see in this the rightmost picture. So we basically try to enlarge the span of source data so to cover the target distribution, and at the same time, we cluster samples around class centers to encourage discriminativity on source data. These are T-SNE visualizations of extracted features from test dataset of CFAR10C, and in the first row, the results show that our approach achieved more compact clusters with larger margins between classes compared to MIADA, which is one of the state-of-the-art methods in single-domain generalization. We also analyzed the distribution of the generated samples in the bottom row. The blue points show the distribution of two classes. We use MIADA and our method to update all samples from the same class. So MIADA is using adversarial loads to update the samples, and it's one of the state-of-the-art approaches for single-domain generalization. The updated samples are shown in orange for both methods. Part A shows some of the generated samples with MIADA shift dramatically and cluster together into surrounding classes. So it may not preserve the discriminative information of the samples. But as you see, our method tends to relocate the samples at the boundary between classes, so it's a better way to expand knowledge space progressively. Thanks for listening. Please come to our poster session to discuss the comments and questions.